Hello, everyone, and thank you so much for joining today's webinar. The webinar is entitled Machine Learning as a Service, and we're specifically going to talk about machine learning as a service on Microsoft Azure. And this is the first webinar in a series in which we are going to introduce you to machine learning as a service step by step. Before we get started with today's webinar, let me just walk you through a couple of logistics. So this webinar is brought to you by Knut Concepts. We are a small data literacy consultancy, and this webinar is powered by T-Systems. And in case you're not familiar, we don't know who T-Systems is. It's the enterprise customer branch of Deutsche Telekom, and Deutsche Telekom is the one of the largest telecommunication companies globally. This webinar is going to be recorded, so in case you want to review that later on, it's going to be available within the next 2 or 3 working days. If you'd like to review the slide deck, it's available in the chat box on the right-hand side. And if you have any questions, feel free to send them through the chat box, and we're going to be responding to those after the presentation or the presentation part of today's webinar. The presentation is going to be approximately around 55 to 60 minutes. So we're going to go slightly over time in case you have to do a hard stop after an hour. Like I said, you're going to get the recording, and please provide your questions, and we're going to answer those at the end of our session. All right, so let's get started. Who is this webinar series for? Well, we are targeting 3 different groups with this webinar. So first of all, business users who want to get started. And what this webinar is going to give you is kind of a foundational practical knowledge, which will enable you to start using Microsoft Azure Machine Learning as a Service at work. The second target group are data scientists who aim to automate and scale their work. So you're going to learn how to automate some parts of your work instead of reinventing the wheel each and every time. And machine learning as a service on Azure is going to enable you to try new things out with little effort, prototype solutions rapidly, and scale fast. And the third target group are developers who aim to transition towards data science and machine learning. And so with this webinar, we're going to explore new promising career opportunities as the glorious days of programming are slowly passing away. Who are we? This webinar is brought to you by, well, I'm Raphael, I'm the CEO of Knut Concepts, and today with me is Arnold. Arnold, thank you so much for joining today's session. Our motto is actually that the best way to learn is by teaching others. So we are just a step ahead of you, our audience, and we share our learnings eagerly with you. We share the things that we like about machine learning on Azure. We share the things that we don't like that much. So we're trying to be as authentic as possible and provide you a very vivid and very realistic user's view on this subject. So I'm kind of the business guy with suit and tie, and Arnold is originally coming from a programming background, so he's the troubled guy with the C# mug. All right, so today's agenda, we're going to be focusing on 6 questions, and we'll try as good as possible to provide answers. And one thing I would like to stress out is that you might not necessarily always agree with us as far as the answer goes, but that's not the key issue. We should focus on the questions. We had a lot of conversations in preparation for this webinar series, and we realized that asking the right questions and focusing on the right questions is more important than providing 100% accurate answers. So what are the questions? First of all, what is artificial intelligence? The second one is, what is machine learning? Followed by, what is deep learning? What is machine learning as a service? What is automated machine learning? And last but not least, what machine learning services does Microsoft Azure provide? So if you are an experienced data scientist, you might feel a little bit bored because you already know many answers to those questions. Nonetheless, we encourage you to stay tuned because this webinar is going to show you how you can actually communicate and how you can engage with the business audience, with a very diverse audience on these subjects. So this webinar might be inspirational for you, and I'm hoping that It's going to help you kind of communicate with greater ease about these subjects with people who are not as familiar with AI, machine learning, and deep learning as you are. And we encourage you to embrace diversity, because if you ask 10 people in your company, what is AI, you're going to get 10 different answers, which means that not that one person is right and everybody else is wrong, but you should actually consider those answers as different angles to one and the same subject. So our motto here is just embrace diversity and make sure that you get as many different viewpoints on these subjects as possible. What is the purpose of this webinar series? We will not provide an in-depth analysis or an in-depth or overarching introduction into AI, machine learning, and deep learning. And as you might guess, that's nearly impossible within one hour. And besides that, there's a lot of great content out there, and we don't want to reinvent the wheel. We will be referencing in forthcoming webinars some of the greatest resources out there. So if you are interested in actually going out and looking under the hood and really understanding the mechanics behind machine learning and deep learning, we're going to provide you a couple of great resources. The purpose of this webinar series is to actually give you actionable real-world knowledge, which you can immediately apply at work. So we want to get things done, and we prefer getting things done than being perfect. So if you just go out and, if you're inspired by this webinar to actually sign up for Microsoft Azure machine learning services and just try things out and break things and just experiment, that's exactly what we want to accomplish with this webinar. We want to get you started using those services. Let me give you a short executive summary, just in case you want to get an overview over the entire webinar, or if you just want to jump off the webinar after 20 or 30 minutes. First of all, what is AI? Like I said, there are different answers to this question, and depending on who you ask, you might get a different answer. One of the ones that we like the most is provided by Andrew Ng, who was a Chinese-American computer scientist and statistician. He was previously working for Alibaba, as far as I remember, and he was the head of AI at the company. He was also giving lectures in Stanford, which I wholeheartedly recommend watching. And his definition is that pretty much anything that a normal person can do in less than 1 second, we can now automate with AI. And that was his answer as of 2016. So if you like this answer, if you believe it's valid as we do, then you're going to realize that there's a huge gap between perception, what oftentimes people think or fear what AI might be capable of, and the reality. So many folks out there have this perception of AI being that kind of superhuman artificial intelligence that's going to rule the world and enslave humanity. But the reality is that we have, devices like Amazon Voice, for example, that very much looks like a can of tuna and is able to recognize your voice and answer simple questions. And on the same note, there's a great definition of what AI is and what it's capable of, provided by François Chollet. François Chollet is a Frenchman, as you might guess. He's an artificial intelligence researcher currently with Google, and he's the author of Keras, which is a leading deep learning framework for Python with 350,000 users and over 700 open source contributors. As of Q2 2019, you can check the current numbers on François' LinkedIn profile. So François, the way he defines AI is just like people tend to overestimate the scope and intelligence of contemporary AI. They tend to underestimate how much you can achieve with these simple and narrow systems when sufficiently scaled and widely deployed. And I think that really nails it. Simple and narrow systems, when sufficiently scaled and widely deployed, you can do a lot of these with these things. So long story short, the slides don't move. Okay, they move. Okay, long story short, AI is almost everywhere. Whether you're using voice assistants like Amazon or Cortana, whether you're taking selfies and you're enhancing those selfies with filters so that you get a pig nose or mouse ears or things like that, or whether you're using Google on your smartphone for, to find a restaurant, you're augmenting reality with your smartphone. Those services are all around the place, and we're using them almost on a daily basis. So that's probably not big news for you, but the point we're trying to make here is that to build those services, it takes enormous effort, it takes enormous resources, it takes enormous brain power, which all these companies have at hand, such as Facebook, Google, and Amazon, to name a few. And what they do smartly is that they provide the foundational technologies of the foundational technology, which enables all those services. They provide the foundational technology as a service in the cloud, so that if you aim to build your own services, you can essentially leverage on their technology and you can consume it very easily through the cloud. And in generally speaking, there are two ways to consume those technologies. And I like the analogy of Lego, and I'm going to be using it a lot, as you've seen on the first slides. You have essentially two options to consume machine learning as a service in the cloud. You can either get a set of bricks that enables you to build something that is specifically defined, like for example in this case, like excavators and those kind of things. The other option that you have at hand is by actually just using the bricks and using the Lego bricks to build whatever you want. But one way or another, the big news is that you don't have to create the bricks yourself. You don't have to create the foundational service itself, because that's the biggest pain point. That's the biggest challenge for virtually every company out there. So who is machine learning as a service for? There are essentially two target audiences that all those companies that are offering machine learning as a service, whether that's Google or IBM or Amazon or Microsoft, are essentially two types of consumers. It's non-tech business people, so that's people like me, for example, who are managers, marketers, sales and finance people who are tech savvy to a certain degree, self-taught. Gartner refers to those people as to citizen data scientists and citizen developers. So what they mean by that is a citizen data scientist is someone who doesn't have a formal education in any STEM discipline. It's not a mathematician, it's not a computer scientist, but it's someone who kind of has a self-taught knowledge about data science. And the same goes with citizen developers. These are not fully fledged professional developers, but people who kind of have some rudimentary understanding. And many companies out there are offering drag and drop UI-based tools that enable you to build data science solutions or to build applications without actually having the in-depth understanding of how these applications work and how they should be built. The other target group are STEMs, so it's science, technology, engineering, mathematicians, and these people might be in different roles within enterprises. They could be developers or data scientists or machine learning engineers. And what we see currently happening is the emergence of a do-it-yourself culture, because if you are consuming machine learning from Microsoft Azure, the infrastructure is essentially being taken care of. So we're hearing a lot about serverless. It doesn't mean that there are no servers anymore, but you don't have to take care of actually deploying servers and making sure that you get the right resources. All these things are essentially being abstracted away in the cloud, and that means that you as the user, whether you are a data scientist or a business user, you essentially have to rely less on IT to get things done, which is actually a very good thing, we believe, and it's going to change a lot for many businesses out there. All right, so let's get into it. Let's get started with the first question on our list, on our agenda. What is artificial intelligence? We've been discussing this question a lot, and as you might guess, we had different views on this subject, and we thought that a very good starting point is actually let's actually make one step back and to ask, what is intelligence? Since artificial intelligence aims to mimic natural intelligence, we realize that it's actually a good idea to ask that question in the first place. What is intelligence? So kind of a very obvious answer to that question is it's the ability to learn or understand or to deal with new or trying situations. That's how Merriam-Webster is defining intelligence. And we found that definition a little bit too narrow, and so we digged a little bit deeper, and we found this definition here on Wikipedia. That wasn't really much of digging, as you might guess. So due to Wikipedia, intelligence is characterized by 7 different traits, and that's logic, understanding, self-awareness, learning, reasoning, creativity, and problem solving. And so let me walk you through those one by one very briefly. So logic is the ability to systematically study whether something is valid or invalid. And some useful words are if, then, therefore, thus, hence. And you can see here a brief, short snippet of Python code. And for those of you guys who are familiar with Python, you know that these logical operations is kind of one of the main pillars of Python, and the ability to solve those problems in a very logical manner. Understanding is a capability of intelligence. So that's the capacity to recognize people, objects, sounds, colors, language, numbers, and to act adequately. That seems like an easy task at first glance, but just imagine the following situation. I mean, we're seeing a picture here of nice and cute animals and a children's book, but our brain's ability to distinguish between just a cute picture and a real animal, that's a huge challenge if you really look into that closely. And so our ability to, well, act accordingly is very important, and it's a highly complex ability that we possess, right? Just imagine watching at a children's book. It looks cute, so you can just lean back. But if it was a real alligator, well, you should definitely leave the room. And there's a tiny line running between an object that is just a picture on a book and a real animal that might be life-threatening. Self-awareness, it's the ability to recognize oneself as a distinct being, and it's the full capacity to observe one's thoughts and actions. So we are one, if not the only species that is fully capable of that. We all know those funny videos on YouTube where cats and dogs are chasing their own mirror, or their own image in their mirror. So we humans have this full capacity. We also have a full capacity to learn, and that is, it's the process of acquiring new or modifying existing knowledge, behaviors, skills, values, and preferences. We're capable of reasoning, which is the capacity for consciously making sense of things, establishing and verifying facts, and applying logic. Creativity, it's the capacity to come up with new ideas seemingly out of nowhere. And it's the capacity for problem solving, which consists of using generic or ad hoc methods in an orderly manner to find solutions to problem. Now, how does that translate to artificial intelligence? Well, artificial intelligence is the attempt to create systems capable of mimicking natural intelligence. And you will find projects out there for each and every capacity, even self-awareness and creativity. We might be decades or maybe even centuries away, but there's still research efforts out there to do exactly that. But we want to be realistic in this webinar series, so we're going to focus on the feasible stuff. So we're not going to be talking about self-awareness and creativity. So we're not going to be talking about those things that are decades or centuries away, but we're going to be focusing only on the stuff that we can use today. And that's the scope of machine learning and deep learning. So let's move on to machine learning. A very quick and brief introduction, how we understand machine learning. And let's start with a use case. Many of you are probably using streaming services. I do that almost on a daily basis. I use Spotify. And so if I'm streaming music, Spotify constantly tries to figure out what's the next song that I would like to hear. So that's a question which is boggling the data scientists at Spotify a lot. And the way to solve this problem is actually by applying machine learning. So what they do is they're essentially using machine learning to make sense of of labeled data. So machine learning has not any awareness whatsoever of the music that I'm listening to, but it actually is very much aware of the tags. So it's aware of the genre, the artist that I'm listening to, the label, the release date, and there are probably hundreds of other labels, if not even thousands, per each song. So if you think of a service like Spotify, which has roughly 30, 40 million songs, and you have potentially hundreds of labels per song, we're talking about billions of data points. And so machine learning is about trying to make sense of that data. So let us look into a definition of machine learning. It's a subset of artificial intelligence involved with the creation of algorithms which can modify itself without human intervention to produce desired output by feeding itself through structured data. That's a definition we found in Hackathon, which we found pretty accurate. Let's take a look at on what deep learning is, and let's again start with a very practical use case. So this is a picture that a friend of mine took of me and a friend during a fair, and Facebook instantly recognized who these people are on the picture. And in this case, you would use deep learning for that purpose. Now, how does deep learning go about data? For a deep learning system, a picture is just a bunch of ones and zeros. It's just a binary, and with deep learning, you're trying to make sense out of that data, and you do that in layers. So you might start with, well, it's actually a picture. What type of picture is it? Well, it's a photograph. What is there on this photograph? Were there humans on the photograph? What are these humans doing? Were they having some sort of they're engaging with each other in some ways. What are the facial expressions of those humans? Well, they seem to have fun. Who are these humans? Well, these are these guys. The chubby guy on the left hand of the left side, it's Raphael. The nice guy on the right hand side is Francis. It's just a very 10,000 foot view on how deep learning works in practice. And so let me give you pretty lengthy but very accurate definition of what deep learning is. So it's a subset of machine learning where algorithms are created and function similar to those in machine learning, but there are numerous layers of these algorithms, each providing a different interpretation to the data it feeds on. So such a network of algorithms are called artificial neural networks, being named so as their functioning as an inspiration, or you might say an attempt at imitating the function of the human neural network present in the brain. So in a nutshell, or in one picture, if you will, if you compare machine learning to deep learning and how these two disciplines fit together, artificial intelligence is kind of the overarching discipline, machine learning is a subdiscipline, and deep learning is kind of a discipline within or a fraction of machine learning. And so the way I like to describe machine learning and deep learning on how they compare to each other is that machine learning tries to make sense of structured data, whereas deep learning is trying to make sense of unstructured data. And we had lengthy debates about that definition prior to this webinar because the lines between those two disciplines are very blurred, and sometimes deep learning is trying to make sense of structured data and vice versa. But by and large, we believe this is sort of a relatively accurate 70% or 80% accurate description or distinction between those two disciplines. So AI, ML, deep learning, it's all about mimicking natural intelligence. And so let me just give you one practical example. I'm actually doing it as an exercise almost every day, and I'm observing myself and other people and humans and see how they're behaving and acting and what it takes to actually do what they do, and how that can possibly translate into an artificial intelligence system. So I have a dog, a very cute one. He's presently sleeping. And whenever I leave my apartment for, let's say, 1 hour or 2 hours, and I come back and I open the door, he receives a truckload of information. So there's zillions of light rays that are landing on this retina, and he's trying to making sense of those data points. And once he recognizes me, the person who just entered the room, he tries to predict what's the best way to actually engage with me. And so he might come to a different conclusion, and very oftentimes it's, well, he just grabs the ball and brings it to me and expect me to play with it. So if you think of that um, everyday situation, it seems so natural and obvious, but it's actually very complex. And if you can just lean back for a minute and just think how complex it is to kind of teach an artificial system to do exactly those things that an animal or a human or both interacting with each other can do, it's really, really very, very, very complex. And Sony came up, I think 2 or 3 years ago, with that artificial dog, and they are essentially trying to um, kind of rebuild from scratch the exact same behaviors that a dog would also show. So if a dog recognizes his owner, he would wag his tail, he would bring a ball, he would bark, and it's extremely, extremely, extremely complex and difficult to do those things. The bottom line here is that if you're thinking about applying AI, machine learning, and deep learning at your company, you might be thinking about super sophisticated use cases, but you should rather focus on kind of the mundane, repetitive tasks that can potentially be automated with help of ML and deep learning. So many people of you might know this guy. I know that we have a lot of people joining us from Germany today. This is Bernd Stromberg. He's the sort of, the equivalent to Ricky Gervais in the British version of The Office. There's, I think, also an American version of The Office. I don't know the name of the actor there. So he's kind of the super smart guy that freaks everyone out. And so if he was talking about, we just imagine that situation, if he was talking about applying machine learning and deep learning at his company, and he was working at an insurance company, the best way to approach this would be like, well, let's use Microsoft automated machine learning capabilities within Azure Machine Learning Service to parse through handwritten insurance claims, convert them into text files, and automatically categorize them, thus speeding up the claim management process, which does not really sound all too sexy, but it actually makes sense. And that's our recommendation for if you want to approach or if you want to try working or experimenting with machine learning and deep learning in your company. If you aim to use AI to solve an unsexy yet relevant business problem, you're probably on the right path. So as an example, if you are working in an insurance company and want to automate insurance claims, which are coming in on paper, and you want to read through the data, you want to categorize the data, that's not that sexy, but it actually makes sense, and it's something that we can do with the systems that are out there. However, if you're trying to use AI to solve a sexy, highly complex problem, you're probably overshooting the target unless you are Microsoft or Google smart, because these companies have truckloads of money and infinite amount of talent. So a good example is AI for fraud detection, which is extremely, extremely complex. And the finance industry, I know that the insurance industry is trying to make sense of AI for fraud detection. But we believe that for the vast majority of companies, focusing on the mundane problems that can be solved is kind of a better approach than trying to shoot for the moon and then essentially end up with having a very complex projects which gets you nowhere. So let's talk about what's machine learning as a service. Large tech companies such as Amazon, Google, Microsoft, and IBM make huge efforts to provide machine learning as a service capabilities to businesses and organizations. So what is it? Machine learning as a service is an umbrella definition of various cloud-based platforms that cover most infrastructure issues such as data pre-processing, model training, and model evaluation with further prediction. And prediction results can be bridged with your internal IT infrastructure through REST APIs. It's a good definition. It's provided by Altexsoft. You can find a link to the blog post at the bottom of the page. And so essentially, we're talking about cloud services here, and it doesn't really matter whether we're talking about a public cloud or a private cloud. Both is feasible. I'm going to talk this towards the end of the presentation, but it's essentially the infrastructure that allows you to do machine learning work. Now, what is automated machine learning by comparison, or complementing machine learning as a service? Machine learning has achieved considerable success in recent years, and an ever-growing number of disciplines rely on it. However, its success crucially relies on human machine learning experts to perform the following tasks, such as, for example, process and clean data, select and construct appropriate features, select an appropriate model family, optimize model hyperparameters, post-process machine learning models, critically analyze the results obtained, and there's probably a lot more. And so the complexity of these tasks is often beyond non-machine learning experts. The rapid growth of machine learning applications has created a demand for off-the-shelf machine learning methods that can be used easily and without expert knowledge. And we call the resulting research area that targets progressive automation of machine learning AutoML. It's a horrible slide. I'm perfectly aware of that, but I promise I'm going to do better in the future, and there's not going to be that many slides with so much text. What machine learning services does Microsoft Azure provide? So if you sign up with Microsoft Azure and you type in machine learning and AI, you get a lot of different services. It's Microsoft currently offers 40 machine learning and deep learning services, and quite frankly, it's pretty complex and difficult to make sense of these services. We're going to be talking towards the end of this webinar about two services specifically, which is Azure Machine Learning Service and Machine Learning Studio. But before we do that, let me show you how we feel the Microsoft Azure Machine Learning Service portfolio feels like to us today. It's more of like, a messy children's room rather than, a well-structured portfolio. But you shouldn't be too harsh on Microsoft, because machine learning as a service is a discipline that is currently evolving, and every company out there that is capable of providing those services is currently experimenting, and they're trying to figure out what is it that the market needs and how should we structure those offerings. And so you get both. You get pre-built, prefabricated solutions, but sometimes you just get a bunch of bricks so that you can build your own stuff, and sometimes you can't distinguish what you're actually getting. But these offerings are consolidating very fast. But the bottom line here is that you shouldn't expect a perfectly manicured portfolio from any of those companies, whether that's Microsoft or Amazon or Google or IBM. So what can you specifically do with those services? One way to look at those services is actually to, well, how can you, what are the capabilities? Just tell me what I can do with these services. And you can categorize all those 40 services into roughly 4 categories. The first one is text analytics and speech recognition. Second, image recognition. Third, audio and video recognition. And fourth, search service. And Microsoft is promoting those services as first to achieve human parity, especially when it comes to vision, speech, and language. So I will not walk through all those 40 services. That would certainly be too exhausting for you. But let me just highlight a few that we find very interesting for each of those sections. So as far as text analytics goes, Microsoft provides great sentiment and keywords analytics capabilities. So for example, if you provide a text, Microsoft Azure Text Analytics is capable of, well, first of all, detecting the language, and it does so in this case with a 100% confidence. It can extract the key phrases. It can analyze the sentiment. So is this text more positive or negative? And it's also capable of listing the named entities in this text. Text analytics also comes with translation capabilities into more than 60 languages. So you can go from English to Chinese, from Chinese to French, from French to Italian, and to English again. And we've tested that actually, and it works very, very well. As far as computer vision or images goes, Microsoft provides great capabilities to extract information from images, to categorize and process visual data. Tagging domain-specific models and descriptions in 4 languages to identify content and label it are also available. Object detection to get location of thousands of objects within an image. and detect potential adult or racial content. That's important if you're, for example, running a social service or a media outlet. Identify images, types, and color schemes and pictures. So you can get this view here. This is a JSON script that provides all the information on this specific picture that was captured. It's also helpful to actually make sense of data that is on packages, for example. So if you are in retail, you can, for example, scan the ingredients of products, and you can actually convert that into the text file. So that's one of the computer vision capabilities that Microsoft Azure Machine Learning as a Service provides. You can obviously get the code as well. And it provides face recognition capabilities. So the ability to detect and compare human faces and organize images into groups based on similarities and identify previous tagged people in images, and it runs locally and on premises in the cloud. So in this case, Microsoft Azure is capable of identifying these two images as one and the same person with a 0.2 confidence, so it's nearly 100%. And in this case, it says, well, these two people, it's actually two different people, even if they look very much the same, but it's not the same person. So as far as audio and speech recognition goes, there's a bunch of great services, like for example, speaker recognition, which is currently in preview. So we can play around with that, and you can experiment, for example, with US presidential inauguration speeches, and the system is going to be capable of recognizing whether that's Ronald Reagan or Donald Trump or Bush Senior or Junior. It offers speech translation capabilities and speech to text capabilities. Custom speech is currently in preview, and it's a great feature, I think, because it helps you overcome speech recognition barriers such as speaking style, vocabulary, and background noise. And you can customize the language model by tailoring it to the vocabulary of the application and the speaking style of your users. And you can also customize the acoustic model of the speech recognizer to better match the expected environment, such as, for example, background noise. Video indexer is very useful if you want to automatically extract spoken words, written text, faces, speakers, celebrities, emotions, topics, brands, and scenes from video and audio files. So let's imagine you are, for example, a fast-moving consumer goods company like Coca-Cola, and you are having a competition on social media, and you ask people to send in pictures with, drinking Coca-Cola and partying. And so video indexer essentially is going to enable you to recognize where is there actually a Coca-Cola can in the picture, what type of people are there in the picture, et cetera, et cetera. You can use video indexer to search by person, object, visual text, spoken words, entity, or emotion. You can create closed captioning on multiple languages and fine-tune recommendations by the objects and people that appear in the video. And you can create new media clips from existing content using sections of video featuring particular person or topic. Knowledge mining. Knowledge mining is a Azure search service that allows you to create searchable content using pre-trained AI models, and you can customize to meet business goals and industry requirements. And it comes paired with Form Recognizer. That's the AI-powered document extraction service, which accurately extracts texts, key value pairs, or tables. So as you can see here, I'm hoping that just going through those services is inspirational for you, so that it might just trigger that thought process. Oh, well, we could use those services for this purpose or that purpose, or in all kinds of possible use cases that are out there. And last but not least, there are AI apps and agents, which is mainly a bot service. So you can develop intelligent enterprise-grade bots that let you maintain control over your data. And it comes with an open SDK and drag and drop services in the future. So you're going to be able to create engaging bots one way or another. Now, how to get started? As you can see, it's quite a lot of services, And Microsoft doesn't make life necessarily easier because they have a confusing number of different services. And sometimes when you look at those services, you just scratch your head and just like, well, they seem to be alike, so what's the difference? So we went through that process and we want to spare you the pain as much as possible. And so first of all, what you should do is just create an Azure free account today. You can get started with 12 months of free services, and depending on the regions, you're going to get credits that might vary from $50 to $200, as far as I know. It sounds like a lot, but you have to be super, super cautious with expenses because they can add up very, very quickly. And we learned it the hard way. We actually started consuming services and we were very cheerful and excited. And all of a sudden you get a bill about a couple hundred or even a couple $1,000s and you're just, what? What have I done? The first thing you should do when you sign up, you should familiarize yourself with the expenses so that you avoid um, you know, bad surprises at the end of each month. Take this advice very, very seriously, please. Once you've signed up, you should take a closer look at two services, which it's a little bit like comparing apples with oranges because these two services have an entirely different scope. Nonetheless, when you do research and you Google those two services, you're going to see that these services are compared very, very often to each other. And so let me just talk about these services for a minute, and let me give you a recommendation with which service to start with. So Azure Machine Learning Studio, that's another lengthy introduction, but it's easily readable. Microsoft Azure Machine Learning Studio is a collaborative drag and drop tool you can use to build, test, and deploy predictive analytics solutions on your data. It gives you an interactive visual workspace to easily build, test, and iterate on a predictive analysis model. And you drag and drop data sets and analysis modules onto an interactive canvas, connecting them together to form an experiment which you run in Machine Learning Studio. To iterate on your model design, you edit the experiment, save and copy it if desired, and run it again. When you're ready, you can convert your training experiment to a predictive experiment and then publish it as a web service so that your model can be easily consumed by custom apps such as, for example, BI tools such as Excel. So in a nutshell, it's a predictive analytics product, if you will, that allows you to actually use machine learning models through a UI interface where you just drag and drop boxes all around the place. So that's a pretty cool thing. Now, by comparison, what is Azure Machine Learning Services? Azure Machine Learning Services is our next generation infrastructure for building and deploying models at scale using any tool or framework. And Azure Machine Learning Service provides end-to-end lifecycle management, keeping track of all your experiments across your entire team, storing code, config, parameter settings, and environment details to make it easy to rank, search, and replicate an experiment done by your team. Once you have a model you like, you can easily encapsulate it in a container and deploy it to Azure on-prem or IoT devices. And it's easy to scale and manage as it is just another container that runs on Kubernetes. And Azure Machine Learning Services makes it easy to start locally in a Python editor or notebook of your choice, and then scale out or out when you need to do so. And this definition is provided by Altexsoft. You can find a great blog post on their webpage, which is covering, which is giving a very good overview over the Microsoft Azure Machine Learning Services. So if you're still a little bit confused, well, what's the difference? Which service should I use and why? Which means Microsoft, we think of those two services as of two different capabilities of the same service. Azure Machine Learning that serve different types of customers. People newer to the machine learning space and those not familiar with coding, analysts, data folks, etc., love the convenience of Azure Machine Learning Studio, whereas professional data scientists and AI developers who are comfortable with Python prefer the capabilities in Azure Machine Learning Service. So that's almost sounds like Azure Machine Learning Studio is kind of like a kindergarten for toddlers, and if you grow up, you then switch to Azure Machine Learning Services. Our recommendation is to actually go straight to Azure Machine Learning Services, regardless whether you are an experienced data scientist or just an early beginner who's coming from, BI or from a data analytics background. Start using Azure Machine Learning Service because in Azure Machine Learning Service, you're going to have all the options to actually work with machine learning models, scale them, test them, et cetera, et cetera. So regardless of whether you prefer a code or no code environment. So first of all, the primary language that is being used in machine learning service is Python. So if you're comfortable using Python, you have two options at hand, and that is you can either use the Azure Machine Learning Python SDK, software development kit, or if you like working with notebooks, Microsoft Azure Machine Learning comes with a notebook that is essentially based on Jupyter notebooks. However, if you're not the type of person who's comfortable writing code in Python, you can have either the Azure Machine Learning visual interface where you just drag and drop and connect boxes, or you have the fully automated machine learning capabilities where you just dump the data and Microsoft Azure does the rest for you. And these two capabilities, the kind of the no-code capabilities, are currently in previous mode on Microsoft machine learning services, but they're going to be fully mature in no time. So we think of Microsoft Azure Machine Learning Studio as of a kind of isolated solution that doesn't really scale very well, as opposed to Azure Machine Learning Service, which is kind of the environment for doing experiments and then scaling them out. So if you want to do your first baby steps and just play around with the Microsoft machine learning capabilities, you can go out and test the zero code automated machine learning capabilities. You can try out the visual drag and drop interface or the code first, either notebook or SDK experience. Microsoft Azure provides some guidance, and we're going to be expanding on that in the forthcoming webinars in October. And you can also go out and just take a look at what other people are doing. There's a web page called Gallery Azure AI, and you can find quite a lot of people there that are sharing their experiments that they're doing on machine learning services and machine learning studio. So let me just give you two examples that I found there, which I found very interesting. So there's one guy, for example, whoops, just one slide too far. There's one guy, for example, who created an experiment where he's trying to make sense of IoT data. So just imagine an assembly line, and he's collecting data on humidity and temperature, and he's trying to predict when and where exactly errors or issues might occur, and where the assembly line or how the assembly line should be maintained. Another great experiment is a breast cancer data set experiment. So the person who created that experiment used breast cancer data from the University of Wisconsin, and the purpose of this experiment is to essentially detect breast cancer tumors in X-ray images. So you can essentially take the data, you can load the data and the entire experiments into your workbench, and you can walk through those experiments and see how it's done and how this person set the experiment up. You can reach out to those folks and you can just ask them if they have questions. So we encourage you to participate and be part of that broader community. If you're a data scientist and you're familiar with open source, that's probably no news for you. But if you're coming from a business BI/data analytics background, and you're probably have been working proprietary tools most of your career, that's probably a pretty significant switch for you to kind of learn and engage with a community. But that's definitely what you should do here. Microsoft is also hosting online hackathons, and you might be already familiar with hackathons on Kaggle, and they're hosting great competitions, and some of the smartest data scientists out there are participating in those hackathons. Now, what's different about Microsoft hackathons is that the purpose of those hackathons is not necessarily to compete on the accuracy of your machine learning or deep learning models, but to actually play around with their technology and to come up with great and unexpected solutions. And so that also even means that you are encouraged to use their automated machine learning capabilities. So that gives you a great opportunity to test their technology and compete with peers and just learn and have fun. Last but not least, there are meetups all over the world. So if you go to that webpage, the link is provided in the presentation. You'll probably find a meetup close to your place, especially in big cities. So I think it's currently like 250 cities globally, and the number of cities that are hosting global AI nights is constantly growing. And I find that joining those meetups and engaging with those folks is extremely helpful and steepens your learning curve. All right, so last two slides before we move to the Q&A section, how to use machine learning as a service at your company. So if you want to go out as an individual and you want to learn and you want to start using machine learning as a service, you can just go ahead and just sign up for machine learning services on Azure on the public cloud. And that's the easiest way to actually start exploring those services. And Microsoft claims that every service that you're going to find on their public cloud, it's also available on premise on their on a service called Microsoft Azure Stack. So how can you make sure that you can consume those services in your company? Now here comes T-Systems to your rescue, because what they do is that they go ahead and they build those services on a private cloud for companies, which are essentially behind gated walls, right? So the business wants it. People who want to build services and products, they want to consume machine learning capabilities. But the challenge for IT is that IT oftentimes does lag behind when it comes to cloud technology, so they don't really know how to handle those technologies. And the risk for your business is to either miss out by essentially not applying those technologies, or if you do it wrong, you might run into trouble, into like security issues, etc. So those are the challenges that T-Systems helps you with. And they have a layered approach to providing those technologies. So the foundational technology obviously is Azure, and or the main building block is Azure. And the foundational services that T-Systems provides is things like managed core resources or managed Active Directories or managed Azure policies. And on top of that, T-Systems provides managed cloud services such as, for example, managed Windows Server or machine learning as a service. So they can essentially deploy those services at your company. And you should know that, even if you're not charged with actually doing this work. But if you're going to talk to your boss and say, you know what, I have played around with machine learning as a service on the public cloud, and there's a company out there called T-Systems, and they can deploy those technologies on premise at our company, you should just keep that in mind. So thank you so much for joining us today. Here's my contact information. I'm going to leave that screen open. We're gonna get started with the Q&A portion of today's webinar. So Arnold, are there any questions that came in during the webinar?
Yeah, there is one question I see.
Sure.
What is your experience? Actually, it's a two-in-one question. It says, what is your experience when you did transitioning from this marketing to this data science and machine learning as a marketing person for you and as a technical guy for me?
Oh, that's a great question. Arnold, you want to go first as the technical guy on board?
Yeah, I started programming, I think a decade ago, more than a decade ago, and I have worked with both startups and multinational corporations. And programming has been fun. It's really hard, a tough kind of work, requires a lot of intelligence, and I would say that yeah, only not everyone can do it. Few can do it, few can do it, very few can do it very well. And all this programming, when it started back in the 1960s and till now in 2015, you can say, we were non-stop creating software, non-stop. There was so much creation of software. And now from this 2015 onwards, what you see, the focus has been changed from creation of software to how to use this software to solve business problems to grow the economy. And like smart cities are coming up, and smart sewerage systems, how to build those. So creation towards the usability, that is the focus I have seen. And I was always a technology guy. I wanted to use software and the technology to solve the problems. And I found that this shift goes aligned with my interests and hobbies. uh, Programming was also my hobby when I came in. And trust me, and in few years from now, programming is slowly fading because the software which you have all created has not been used that much. The usability is coming now, and machine learning, this data science, it has been actually is going to be the as a prime factor in putting the usability of software into the world. That is how I see it. Rafael, you.
Yeah, sure, thanks. So I'm representing the exact opposite of that scale. So I started out as a marketing guy. So the only technology I was familiar with was PowerPoint, and I hated Excel. So the only way I used Excel is just to make lists. But eventually, by I think 2012, when there was a lot of hype around programming and all these massive open online courses popped up, and there was so much craze about programming that everyone should learn to program, I catched fire and I thought, well, that's something that I should do. And I had this feeling that if I miss on that opportunity, um, I might essentially get flushed out of the job market in a couple of years from now. So that was kind of my fear and my concern. And so I started to teach myself to code, and it was a horrible learning experience in the beginning because I felt that my brain is absolutely not wired for that experience. However, over time, I kind of actually developed a sympathy for programming, and it taught me a lot of things. It taught me many things beyond programming, how to actually approach and solve business problems, how to break them down into tiny little pieces, how to experiment with solutions, how to collaborate with an open source community, and that was an extremely important learning for me. And over the last 2 years, I realized that there's a great opportunity with actually making sense of the data, the vast amount of data that companies are being flushed with today, and that the services are emerging right now that enable companies to do that at scale, and even without having a formal degree in mathematics or computer science or both. And I thought, wow, that's a great opportunity. I mean, for people like me to actually reinvent themselves and to create entirely new job roles for ourselves. There's research out there, I think it was McKinsey, that by 2030, roughly 650 million people going to need to be retrained due to the advancements in technology. So I want to make sure I don't miss on that opportunity. And I also wanted to point out to what Arnaud just said. He is a programmer, he's coming from C, and I have the deepest respect to people who are able to code in C. um, I'm just
Thank
a
you so
tiny little
much.
Python guy. I just got my feet wet with Python, and I can kind of do some work and looking things up on Overstack. That's my main skill here. Um, but I think what we have in common, regardless of our background, whether you are a data scientist or the so-called citizen data scientist, who is essentially a jack of all trades like I am, what we have in common is that we are actually what the we have a joint interest in actually solving problems, and that essentially helps us get on the same page. So that's always a starting point when we are getting into customer projects, is what's the problem that we want to solve, and how does technology support us to get there. And so if I can give you specific advice on how to get started, is don't be afraid of coding. That's number one. So if you, for example, if you're familiar using Excel, if you like using Excel, then just grasping the very basic concepts of Python should come easy to you. you should not necessarily spend too much time trying to have an in-depth understanding of machine learning or deep learning, because these are extremely complex disciplines. Instead, focusing on building knowledge on how to actually use those technologies. And with that being said, it's extremely important to understand the newer database infrastructures such as Hadoop, for example, to learn about how to actually work with data at scale. And last but not least, you have to understand costs. It's probably the least, the most unsexy area of machine learning. But if you don't get costs right, you will not be able to actually make sense of those technologies, because they come at a price, and you need to understand how much money do you need and what resources do you need to allocate in order to solve a specific business problem, and are those resources that you're allocating, are they appropriate, or are you just overshooting? So that's my answer. Any additions to that, Arnold? Any additions, Arnold?
Oh yeah, one more question.
Mhm.
Uh, any any concrete idea on the costs they are saying?
Any concrete idea on the cost? Well,
Yeah.
um, it's
Can I
it's
answer that?
yes.
Okay. See, when you start using these services, so like Rafael said in the webinar, that they call serverless, but actually server is there. It is just not on your computer or your laptop. It is with the Microsoft. You are accessing it through your web browser. And when the server runs over there, the hardware and the software, it is being used, and it is going to cost you. And since it is the beginning of AI and machine learning era, and it is not pretty clear how much exactly a service costs before you start using it. You can have an estimate, but it is not cheap. So my advice would be to look at the pricing section carefully and make up an estimate, and use it a bit for, let us say, some time, rather than going full-fledged and start doing everything. It is a very basic kind of advice, but that's all you can get in this time right now.
Yeah, and it's let me make you one addition here.
Yeah.
So very often you get a bill and then you understand the costs. And you don't understand them because you got the bill, but you are talking back and forth with Microsoft support. Always make sure that you run very small experiments with very small data, and you should never, please promise that you're going to be not be doing this. You should never ever um, use a service and then not terminate the service when you don't. Whenever you stop using a service after a few hours, terminate it. For God's sake, please terminate the service. Because if you keep it running in the background, and sometimes you might keep running it for days or sometimes even weeks, all of a sudden you get a bill of hundreds or even thousands of dollars, and you're just freaking out. So in order to avoid that, just shut down every single service that you're not using, and make sure that every instant of that service is terminated. If you don't do that, prepare yourself for bad surprises. It's I don't blame Microsoft necessarily for that, because since we're talking about serverless, so we're having an infrastructure that Microsoft takes care of. It essentially abstracts all the complexities away, but the complexities are still there. And there are resources that are being used. And these are complex services. And so sometimes when you request from support a log file and you say, I want to look into the costs. So we've been using, for example, a service for 2 hours or for just 5 hours, I think. And we got a bill of like $270, and we wanted to understand the expenses. And so we got a log file that has 200 rows. I think it's within 230 rows, and that was just for consuming a service for just 3 or 4 hours. Um, So I think it's a good exercise to just experiment, but make sure you make small experiments. You don't overshoot, and you just see what expenses occur, and then reach out to support and ask them what the expenses are specifically. Look up in the documentation and just familiarize yourself. And as you become more confident using those services, and as you become more confident spending money and having full control over your budget, you're gonna essentially scale out. But that's what you should definitely do. All right. Do we have any other questions, Arnold, or is that?
How does it compare to AWS?
Oh, that's a very good one. They're very different. Arnold, do you want to take about that? We did a webinar series on Amazon services
Yeah,
last few
yeah.
months. So
So AWS is Amazon Web Services for everyone else. Just one. The thing with the Microsoft and AWS and Google, these are the three giants, and then IBM is also there, the fourth one. I will say they offer same cloud-based machine learning and data analysis services, but the interface is very different, and sometimes the services are divided into, like, let us say Amazon is offering one service. Microsoft may divide the service into four parts and offer them in four different ways. This is the way this is the way actually we have experienced it. And the pricing is also different for the different services. And Microsoft has larger collection of services, if you ask. And but if you ask about the largest user base, that Amazon has it, because they were the first ones to bring cloud-based all these data center services over there.
yeah,
Yeah, that's about it.
yeah. I
No more.
think I think yeah. I think that my impression is that Microsoft is kind of, since they have been hardwired into the enterprise space for decades. I think that they have enterprise in their DNA, so they understand their customers very well, and so that way they're kind of able to build services that are relevant to the enterprise customer base. And I've also seen that my observation is that Microsoft Grip makes huge efforts to actually make those services work with each other, which was not always the case in the past, right? Sometimes you had great services, service A, service B, but they wouldn't talk to each other. I think this is changing right now under the new leadership. And so, for example, if you want to use, let's say, machine learning or machine learning as a service on Azure to, for example, read through paper documents and make sense of those documents and categorize them, you can essentially connect this with a service called Flow, which enables you to actually create entire workflows. And so all of a sudden you got an RPA, robotic process automation service that you're able to build using Microsoft Azure. So just to sum things up, I think it's a great choice for enterprises. But most companies that we work with, they never bet on one vendor, but they typically have a dual vendor strategy. So they work with Azure and with AWS simultaneously. One question that just came in, I see, is what's the scope of the next webinars, and when do they take place? So we're gonna provide a couple of experiments. So we're gonna provide you a step-by-step demo how to set up your first experiments on Microsoft machine learning service. And the webinars are going to take place towards the second half of October. We don't have the exact dates yet, but we have all your emails. So we're gonna send you an email once we know when these webinars are going to exactly take place. And I think that's pretty much it for today. So thank you so much for joining us today. We went a little bit over time. And if you want to review the handout, it's in the handout section, so you can just download it. And the recording of this webinar is going to be available the first half of next week. So with that, Arnold, thank you so much for joining me today. Thank you everyone for joining us today. Feel free to shoot me an email if you have any questions or suggestions or feedback on how we did in the first webinar and how we can do better next time. And I'm hoping to see you again in October. Have a great day and great evening, depending on your geography, and talk to you soon.